Software architecture is the blueprint for a software system, defining its major components and how they interact. Just as an architect plans a building to ensure stability and future growth, software architecture organizes code for reliability and scalability. Architectural patterns are like recipes, proven templates for solving common design challenges. They help teams avoid reinventing the wheel and create a shared language for collaboration. Patterns like Model View Controller (MVC) separate concerns, making systems easier to understand and maintain. The main goal of architecture is to manage complexity by breaking systems into manageable pieces. This structure allows for easier building, testing, and evolving of software over time. Without a solid architecture, software becomes chaotic, hard to maintain, and difficult to scale. Using established patterns leads to more robust and maintainable systems. Teams benefit from clear boundaries and rules for how parts interact. A well-architected system can adapt to new requirements without a complete rewrite. Just as a building can be renovated, good software architecture allows for growth and change. Ultimately, architecture is about creating a foundation for long-term success. Good software architecture relies on core principles like abstraction, modularity, and separation of concerns. Abstraction hides complexity behind simple interfaces, like driving a car without knowing how the engine works. Modularity breaks a system into independent modules, each handling a specific responsibility. Separation of concerns ensures changes in one part don't break another, making maintenance easier. Scalability is crucial. Systems must handle growth by adding resources vertically or horizontally. Patterns like microservices and client-server support scaling to meet demand. Maintainability means systems can be easily updated or fixed. Security must be built in from the start, protecting data and users. These principles make software easier to build, adapt, and secure. They're the backbone of any successful architecture. Several architectural patterns shape modern software. The layered architecture organizes code into layers: presentation, business logic, and data access, making updates and maintenance straightforward. The client-server pattern powers the internet. Servers provide resources, clients request them, and scaling is as simple as adding more servers. Microservices break applications into small, independent services, each focused on a specific business function. This allows teams to develop, deploy, and scale parts of the system independently. However, microservices add complexity in managing communication and data consistency. The event bus, publish-subscribe pattern lets components communicate through a central message bus. Publishers send events, subscribers react without knowing each other directly. This decouples components, enabling real-time responsiveness and independent evolution. Each pattern has strengths and trade-offs fitting different needs. Layered is simple and clear, microservices are flexible, and event bus is great for real-time systems. Choosing the right pattern depends on your project's goals and scale. Understanding these designs is key to building effective software. Picking the right architecture shapes your project's future. Start by understanding your requirements, user needs, performance, and scalability. Simple apps may thrive with layered architecture. Large, evolving systems might need microservices or event bus. Team experience matters. Complex patterns require advanced skills and tools. It's often better to start simple and evolve as needed. Consider how the system will grow. Will it need frequent updates or rapid scaling? Every pattern has trade-offs. Simplicity versus flexibility, ease versus complexity. The best choice balances project needs, team strengths, and long-term vision. Thoughtful selection sets the stage for success. Software architecture is evolving with trends like cloud computing and AI. Cloud platforms make deploying and scaling patterns like microservices easier than ever. AI and machine learning introduce new challenges, requiring data-centric and adaptable designs. Despite changing technologies, core principles, modularity, scalability, security, remain vital. A strong architecture enables innovation and resilience in a fast-changing world. The right pattern guides development, collaboration, and long-term reliability. By focusing on requirements, team skills, and future needs, you build systems ready for tomorrow. Good architecture is the foundation for lasting success.